Hello YouTube, I hope everybody's doing great. Today I had a very early start, could not sleep, and I had printed this base overnight. It was a 7-hour print and I showed it to you, and I will add it now after this short intro. So I did make a new watch winder and I will show you now and talk about it, and then at the end I will show you how it exactly works. So actually it's 6:15, about 6:15 in the morning, and this is a 7-hour print, and I will make the beginning, I will record the beginning of the video later on. So now I wanted to show you this and look at it myself, how it did turn out. This is another watch winder. I have this here. This was my first, and I did use, this is actually magnetically detachable. So I found, no, actually I made this as well, and yeah, back then I had only one. This was my first automatic watch, Seiko, and well, this is okay, it works, and I made this so I can put the watch on here, take it off, put the watch on here, and then put it back on. It is quite a little bit bigger than I would like, but the main reason is this is one size. Although I did print it out of TPU, does not make much difference, only one size fits on here. And since the watch is turning, there's the possibility that the watch will slide off and fall off this holder. And I have 3 watches, one person, and they're all different. This one is the tightest actually. If I add a link, then it's too loose, and you see it here in on my wrist. It's actually too tight, and I wear this at night because it has the most lume. This is what I wear during the day, and this is what I wear actually the most because this is my newest one with my own carbon fiber dial. So anyway, what I did not like about this was the holder design. And I have a basic stand. These are perfect to put your non-automatic watches, and they have this interlocking system where you can just put them next to each other. I will put those in another video. I will show those in another video. And then I did find this holder, which kinda does flex and holds the watch. I won't show that thing yet, hold on. But it's still, as you can see, even though it has this springy effect, over time, if I use this design, it will slide off and make a lot of noise. And I looked on Thingiverse and on all the usual suspects for a design that would hold different sized watches, and I did find this. It has this spring, and it happens to have the right size for my wrist. I have a relatively small wrist, I think it's 7 inches, and this was perfect for holding a watch. You can just squeeze it together, put your watch on, let it go, and it will hold it with the spring pressure. I did change the bottom a little bit. I did put 2 holes in it. This base I made so I can screw this together, and this goes over these mostly used stepper motors for these builds, for the DIY watch winder builds. And I did not like that this side was closed, and I was still afraid that it might, depending on the spring strength. I have here a slightly shorter one, that it will still be able to slip off. So then I edited the design. First I made this cutout, so now it actually looks a bit nicer. But most importantly, I made these 2, how you call it, not cutouts, but indentions, or whatever you want to call them. So this way the watch goes on. It's just because it's still the same. Once the watch goes on, you did hear it click. So the band goes in between the cutouts on the top and the bottom, and the spring pushes against it, and now this thing is not going anywhere. So that's my addition to this great design. I want to thank the original designer. Just push it together and then push the watch out. And no matter how big or small, and I made this for 22mm bands, the cutout here, and I think 20 and 22 is the most common, and you hear it click in, and now it's not going anywhere. Plus it does look cooler where you can see the spring mechanism in here. Very simple design, but very effective. I think it's the best one out there. I saw many other ones that had like pegs sticking out, that they had a big holder, they had the pegs, and then you could individually adjust them. They had like long holes in there where you could adjust the peg to your size, but then it was still a big possibility of it sliding out. And then if you have any watch that has a slightly different size, it will just slide off and not fit. The spring design is, I think, the best holder for I was gonna say OTF. Yeah, here's one OTF. I don't know why I said OTF now. DIY watch winder holder. I think this is the best design, and if I say so myself, I think I made it a little bit I think it must be the time. It comes out easy, of course, and I think I made it a little better looking, or save time on your printing. Although these print fairly fast, 2-piece design, very simple two-piece design, one spring. Oh, I did edit the inside here, the diameter of this. It was a smaller diameter, and the springs I had were these bigger ones. This is slightly shorter one, and these are 10 millimeters outside, 8 millimeters inside, and this one is, I think, 40 millimeters long. Or was the other ones that were 40? No, this one is 32, and these were, I think, 40 millimeter long springs. Oops. So anyway, this was the top of it, and then I needed something other than that to have as my bottom, and now finally I come to it, and then I designed this here. I did print it in ABS. It was a difficult birth, 7 hours, and I'm using Cura, by the way, and I like how these supports come out very easily. I'm gonna get me a little bit help. So this is like kind of accordion style. You gotta clever. See the support, kind of cool, and they really come out easy. See that? Oops, going all over the place. And I put a hole there. And this is the first time I'm seeing it myself, obviously. Yeah, that surface, the front looks nice. And this design didn't have any switches, no external input. And then I found this great code. I think it's called the Open Watch Winder code, and even the bottom comes out. I mean, Cura is really great. All the supports come out very easy. A little bit of there, and this turned out really nice. Gotta cut that a little bit. Oh, my mouth is dry. Let me have a sip of water. And once you go with the heat gun over this, I actually use my desoldering equipment, and you see that little bit white, it will all turn nice black and look nice. So here is the motor, the stepper motor, and I made a little cutout here for the wires. And this might be too tight because in this build here I use TPU, where the motor did slide in, and this is ABS, so tolerances are different, and I have to enlarge this a little bit. So, and this was my first print, so I will do that, make that a little bit bigger on the next one so it does not fit, but doesn't matter. I wanted to see how this will work out, and I have these smaller stepper drivers which happen to fit perfectly on my mini Atmega board that I have here. This is actually my Atmega board for my GPS tracker, and this just fits in here, on here. And then this code has a button where you can, with the LED indicator, and where you can stop the running of the turning of the watch, and you can see when it's gonna start again. And of course in the code you can change the interval and the number of rotations and the speed to do all that. And I have also here my OLED this is the OLED Max PCB, again on the Mega 328. This is practically Arduino Uno. But much smaller and way better. So anyway, and on this again, this driver board fits perfectly onto this way around, onto the bottom pins. And on this one I might do it for the next version of this, might add an OLED display which goes up here, and then this goes on the bottom like that, and you have the very compact and the smallest possible way to, where's the motor, to drive these stepper motors. I might shorten the wire here as well, way too long. And on this build I will use it probably without the display. I will use this one, but on the next version I will make another one. I will use it with a display, and the display will sit here, and I don't know where I'm gonna put the button. This is actually a 12mm button switch, and I have a 10mm as well. So this one was for the 10mm, and let me see if that fits. Yeah, I guess ABS does shrink more, but you get the idea. You will have this nice button, and you can start and stop the winder at will, and it does indicate through slow blinking, fast blinking, or breathing in which status it is. And this one has actually, for the non-display version, my PCB fits in here easily, and obviously the motor will sit in here, and this will then be like that. And I wanted to have it as compact as possible, because this one is wider. Well, it's shorter in this dimension, and let's see if we have it a height difference. Oh yeah, what do I know, quite a bit height difference. But of course the best part is the spring version and these cutouts here for the watch band to make it impossible for the watch to slide out. Hear it clicking. And I will of course share my design, what this version also has, it's very easy to tip forward once the watch is on here, but I made it smaller because it was actually too big. But anyway, that's out of commission now, and this will be my new watch winder, and I need obviously 3 of them. I could get by with having this on the watch winder and then wearing this during the day and this during the night, but since I have 3, I want to have 3 watch winders, so I will have to order more stepper motors and more of these smaller drivers. In here there is a bigger board that's twice as wide and has a deep version of this chip, so it's much larger. And I wish I could actually, maybe on the next version, extend these LEDs to the outsides, because what the other code did not have was soft start and soft stop. So it started and then it stopped the steps, and it did lose steps. This actually has a magnet and a hall sensor to find the starting point, so it's like perfectly upright. And but once it runs, it does get out of whack. And on this, on the other code that's running on here, it ramps up the speed, turns, and then slows down to a stop. And on my testing on the bench, it did not lose any steps, and it was always perfectly dead on. That's why this design does not have a end stop. I might add it on the other one. I'm not sure if I'm gonna use it or not, but it will be there, and it could be integrated in the code. And yeah. Oh, okay. So I'm always looking here at the center, and I'm thinking, oh, this could be a little higher. It does go a little higher, because since this stepper motor has gears inside, the output shaft is higher, and I did measure it, so it will be like this on the top. And yeah, I like it. So this was my morning video. It took way longer than I thought, but I will make a short intro and fix this, and short outro to not make it too long. And well, I have the height of the switch. I might be able to make it a little lower in the case, but still you will be able to push the button, the switch, with no problem. Anyway, off to the next segment. So if you're still with me after it turned out longer than I thought it will. So this was my first version, and well, it does look nice. It has a big disadvantage: it only fits one size. And since I have actually all 3 watches have slightly different sizes, this one is the loosest. This one is loose as well, but this one is kind of tight on my wrist, as you saw. So this one, it's very hard to put on here, take it off, and it only fits this one and not the other ones. Plus it's TPU, and it's kind of sagged over, although it's screwed in. But so this was no bueno. Anyway, so I talked about all this. I won't go again. You If you're still with me, you saw that, and now you see the finished product. And on this one I just had a whole wire out. On the next one I will make the edges different, and I will have a USB Type-C plug back here, so no wire tangling out, and you can just plug in your wire, and 5 volt, you can run it off a USB hub like I'm doing now of your PC. And anyway, it has this nice button, and it's right now it's glowing. 1 second please. It's breathing actually, and the code for this I did find, and it's called OpenWatch Winder code. I will link to it in the description. And what it does is, when you turn it on the first time, I just turned it off here and turn it on. Excuse me. It will wait for your input. As soon as you hit the button, it will start winding. You can adjust the rotation number, rotation speed, how many times left, how many times right you want to turn it, and what else, and how long it should pause between the rotations. You can adjust all that in the code. And short version of the manual, as the author described it: click the button to start winding, which is that. Long press the button to stop winding. So anywhere you long press it, it blinks fast and it will go to the starting position and then stop. And you can also toggle the LED. It did stop. When you double click the button, you will toggle the LED. See, now it's off. I actually hadn't tried that. So if the LED bothers you, there are people like that, you can turn it off. So once you start winding again or rotating, where is it? Okay, by clicking the button while the winder is in standby, it will start winding. When long pressing the button while it's winding, it will return to the home position and stop winding. When long pressing the button while it is waiting for the next cycle, it will stop winding. Stop winding, okay. When clicking the button while it's waiting for the next cycle, it will start winding immediately. So if you want to see it, or if you want to have it wind, you can do that. And double clicking the button in any state, LED will turn off if it was on, or the other way around. So that's the menu for this. Long pressing will return and stop it. And there's also, where was it? And double click the button, and the LED will turn off. It was on or on. Oh, okay. When it's winding, as it is now, and you long press the button, it will return to the home position, stop wind, and stop winding. It won't wind anymore until you again initiate it to wind. So like this, it's not gonna do anything until you recycle the power and then push the button, or push the button while it's on there, and then it will recycle, turn the amount of times that you have in your code, and then stop for the pause that you have, and then start winding again. So that's the workings of the code. Let me just stop this again for a second. And while it's stopping, it does blink faster. And okay, I forgot. Once it completes the cycle on its own, It will then slowly breathe the LED until the next cycle starts, and 1 minute before starting the cycle it will blink fast again to indicate you that it will start within a minute. So that's also in the code, which I didn't have to do anything. I just adjusted the rotation speed, which I lowered. It was at 1000, I lowered it to 800. Paused, I have 10-minute pause and 3 rotations, 3 cycles and 3 rotations left, 3 rotations right. So, and this is how it looks like. I am gonna print this again, and here I just put my electronics in. I will also make probably a lid for the bottom. I put my silicone feet on it so it won't slide back and forth. And I will reprint this with, I had here bevels, sharp bevels, and I will make rounded bevels on the next version. And I will 3D print this part again to make it sit flush or closer to the base. Right now you can see, and it's also not all the way on there, I think. But I will make it, this is 10 millimeters now, I will make it 12 millimeters so it will sit closer to the base. And this is it. This is my new winder. I like it. I wanted to have it short as possible, and I did make it as wide as I needed to cover the stepper motor with the bracket. The first bracket has this one is only 46 millimeters in diameter, this one 52, and the base is 56 millimeters wide, 80 millimeters long, and 60 millimeters high. And I wanted to have it stable, so even from this position on it will not flip towards the front. So right now it's stable, it will not move, fall out or whatever. And in this version I also don't have an end stop, but this code, since it's ramping up the speed and then slowing down before stopping and then turning the other way, I don't have an end stop. On the next version I will put an end stop in there. I don't know if I'm gonna use it in the code yet, because I wanna run this, and if it runs without losing steps, then there is no need to add an extra Hall sensor and edit the code and whatnot. And if you turn it by accident while taking the clock off, the watch off and on, kind of tricky because of the lip, it only happens on the camera. Oh, come on. That's embarrassing. Okay. Maybe I should edit this to make it a little smaller. This way. And what was I going to say? Oh, okay. And if it's kind of off when you're trying to put your watch on and off, you can just adjust it to have it center, and that's for picky people like me. And then once you start, it will stay that way. And I will run it now that it's finished, this version. I will run it and see if it does lose any steps, if it does need alignment, and then I will put the Hall sensor in and make a end stop. But anyway, this is it. Thanks for watching and take care, everybody.